Welcome back, Science 9 students. Today we're going to learn about heat and thermodynamics, and we're going to learn about how heat can be transferred. So as you can see here, the opening slide's got our Newton's cradle. The kinetic energy of this hits here, that one goes up in the air. You guys have seen this before, we have used this quite a bit. Now there's going to be a transfer of heat as well throughout here, and we're going to talk about how that's going to be conduction. And that's actually our first vocab word here. Conduction is going to be the transfer of thermal energy with no overall transfer of matter. So I'll give you an example of conduction. We've looked at this before. When my hand is touching here, it's actually transferring the thermal energy from my hand to the countertop. So conduction has to be touching. That's kind of the big key point there. Conduction in gases is going to be slower than in liquids and solids because the particles collide less often. So like it says here, conduction occurs when materials are touching. So that's kind of the key word there. In conduction, the collisions between the particles transfers this thermal energy. So like my hand right here, the molecules in it is moving faster than this countertop, so it actually collides with the countertop particles, increasing their speed, which is going to increase their temperature. So we're going to have what's called a thermal conductor. This is a material that conducts thermal energy well. You guys probably know that metals are excellent thermal conductors. So like you have here is a skillet, iron skillet, that definitely transfers the thermal energy very, very well. So obviously, we'll just kind of skip over that. Insulators, on the other hand, are materials that conduct thermal energy poorly. Will be called a thermal insulator. So like the air around us is a good thermal insulator because it's a gas again. Wool garments are very good insulators. Plastic foam cups just slows down conduction. Another way that heat can be transferred is through convection. This is going to be a transfer of thermal energy when particles of a fluid move from one place to another. Convection happens in the ocean. Convection happens right below our feet here with the earth. So the earth's molten lavas, heat rises, then it cools when it reaches the surface, goes back down, creates these convection currents. The big key thing to understand with convection currents is hot air rises. So like in this room, if we had a thermometer, we would be able to see that the hottest air is at the top of this room and the cold air would be at the bottom. So hot air rises, that's just like any other material. So if you're looking at this, well, it's called a convection oven for a reason, because it creates these convection currents and it cooks your food evenly. So you got the warm air is being heated up from the coils at the bottom of the oven. It rises to the top where it gets a little bit cooler, and then the cooler air comes back down and then gets reheated back up. So this would be called a convection current. Like I said, this happens in our earth right now. So you can think of this as being the warm lava raising up, reaches the surface of the earth, goes back down because the cold air sinks, and then, or even the lava if you want to say, will get down to the middle of the earth again and then re-raise back up. So convection currents happens in the oceans too. It's actually what keeps, so it's what transfers the warm water. So different parts of the earth has different temperatures there. All right, so that's